Hey everyone, welcome to I Teach You Science. Today we're going to be checking out the Earth and Space Science NISLIS January 23rd, 2026 Regents exam. I have never seen this, so we're going to do it together. If you want to pause the video as you do the question and then you could hit play and see how I solve it, that might be the best thing to do. Otherwise, we're going to start with question 1. All right, it says base your answers to question 1 through 3 on the information below, and we have our reference table ready to go here. Make sure you have yours, and this says evidence for the Big Bang Theory. I'm going to highlight as I go, and you'll see the important things that I think are worth highlighting. I would definitely have a highlighter on these tests. So here we go. The Big Bang is a physical theory that describes how the universe expanded, okay, from an initial state of high density and high temperature. The theory attempts to explain how the universe has changed over time. 3 pieces of evidence are used to support the theory. The measured amount of elements in the universe, okay. The observed expansion of space, that is accelerating, is another piece of evidence. Also, the discovery of cosmic microwave background radiation, CMBR, supports the theory. The model below shows some information about how the universe has changed since the Big Bang event. Temperatures in the model are in kelvins, so something about temperature. So that's kind of what I pulled from that. And we're going to look at this. We got a lot going on here. So we got the Big Bang, protons form, fusion begins, fusion ends. And it tells you what years that happened at. 20 minutes, 300,000 years, and then modern universe, it does tell us 13.8 billion years, which this might be coming in handy later on if we forget how old the universe is. And there's a bunch of information down here. Okay, so let's just go jump down to the question and see what they need. Complete each of the 3 statements below to correctly describe cosmic microwave background radiation by placing an X in the box to indicate we need to, which phrase correctly completes the statement. Okay, so here we go. Cosmic microwave background radiation provides evidence of the Big Bang. So we needed to provide evidence because it is what? It is energy predicted by scientists that is distributed throughout the universe. Yeah, it is. So that could be right, but we'll see. It is matter that is fused to become elements. No. So we're going to go with energy. Right there. Oh, see, I already messed up. It says place an X. I didn't follow the directions. Place an X. Okay. So for statement 2, cosmic microwave background radiation is able to be detected because the universe did what? The universe initially did rapidly expand due to heat, but the cosmic microwave background radiation is able to be detected because the universe is cooling down and then became transparent. Let's see. So it says universe transparent right here. And then let's see if we can get, look, 10 billion Kelvin right there. And now it's 3000 Kelvin. So it did cool. So we want cooled and then became transparent. And then it's saying cosmic microwave background variations in the universe caused by density differences indicate that what? So do we want galaxies to form at high density or galaxies to form in low density? We're definitely going to want the galaxies to form at high density. The galaxies up here, these spiral galaxies right there, they need a lot of material to form. So yeah, we're going to want a lot of dense material to get those galaxies to form. So that was question 1. A little tricky. I like to rate these on a scale of 1 to 10, so I would say this question is like a solid 5. Right there. Let's see how we do. All right, in the 1920s, we're going to grab our highlighter. Astronomer Edwin Hubble studied galaxies using a type of star called a Cepheid variable. Cepheid variable. I've never heard of this before, but it's probably going to tell us what it is. These types of stars brighten and fade in a predictable pattern. Okay. Hubble observed these stars to determine how far away these stars and the galaxy in which they are located are from Earth. So we can find the galaxy and how far from Earth. Okay. A reproduction of the graph is shown. Recessional velocity of a galaxy, so the speed is plotted as a function of distance from the Earth to the galaxy. It's measured in parsecs, so that's just like a distance. Galaxies traveling toward Earth have negative recessional velocities. Okay. Well, let's see what this says. Distance from Earth is here, and then our recessional velocity here. So it's a direct relationship. So we could say, just from this graph, I don't know what the question is, as distance increases, the velocity increases. So this is Hubble's law. You should have learned this in Space Systems Unit. So this is saying the further away the galaxy is, the faster it's moving. This helps explain that the universe is expanding. Wow. Okay, so several statements about Hubble's work related to galaxies are listed below. There's a lot of statements. Which statement correctly summarizes Hubble's data as evidence to support the Big Bang? Okay, so we want to look for the correct evidence to support the Big Bang. Okay, we're just going to go and we're going to see if we can highlight the ones we think support the Big Bang. Hubble's graph shows that there is no relationship. Wrong. We already established that there is a relationship, though. This one is wrong. Oh, let's say that's wrong. The evidence for speeds of most galaxies on Hubble graph was most likely obtained from redshift data. Maybe. I mean, we see redshift in there, so that could be true. So let's say maybe on that one. Galaxies measured by Hubble that were 2 times 10 to the 6 parsecs away from Earth all have a recessional velocity greater than 500. So we're going to check. So we got to go 2 times 10 to the 6 right here. And we're going to go up here and we're going to say this spot everywhere there and up is greater than 500. That would be right. Oh, but is it saying these dots? Are they all greater than 500? Even if they are the dots and not the best fit line, it's probably the dots, then yes, they're above 500, so that works. Okay, Hubble's graph shows a proportional relationship between distance of a galaxy from Earth and the galaxy's recessional velocity. A proportional relationship. It's probably not true because everything is kind of scattery. That one's weird. That is really hard words right there. But that could mean, does that mean direct? We're gonna have to put a question mark there. We'll see if it works out with the choices here. Some galaxies shown on Hubble's graph are traveling slower as they get further. No, that's wrong. And then the evidence for speeds of most galaxies on the graph was most likely obtained from blue shifting. No, blue shift data would mean the galaxies are moving towards us. So these are all moving away. So that one's out. So that leaves 2, 3, 4 as possibilities. So I'm going to say that is the answer. So this is tricky. I didn't like this word. I didn't like it. It's kind of weird. I mean, I guess they meant like direct relationship, proportional, in which case it is true. So, but the good thing is 1, 5, and 6 are completely wrong. So it cannot be 1, 5, or 6. So I would say, honestly, based on 1, 5, and 6 and how wrong they are, this is probably a 3. Question was pretty easy. All right, number 3. How does the data in the graph, we're going to grab our highlighter, support an explanation of the Big Bang Theory? So it just wants us to look at the graph. Okay, let's just go one by one. We're going to eliminate. Galaxies farther from Earth has greater recessional velocities indicating an expanding universe. That's the right answer. I mean, that I already know it's going to be, but we're going to check. Number 2, galaxies closer to Earth have negative recessional velocities. No. They said in the reading that negative recessional velocity means that it's traveling towards, right? I got that right? Yeah, traveling towards the Earth. So that is incorrect automatically. Galaxies located approximately 1 million or 10 to the 6 parsecs away from Earth are traveling towards and away from the Earth? No, they're all traveling away. Galaxies travel away at constant speed, indicating that the universe is expanding at a constant rate. This is wrong because the further away you go, the faster it goes. So it's wrong. So we knew 1 was the answer initially. That is a very easy question. That's a 2 out of 10. All right. The table below shows some information about two stars in the Milky Way galaxy. So we got two stars. Okay, Betelgeuse here and the sun. So they're comparing Betelgeuse and the sun. Now the first thing I'm thinking of is the reference table. So if we go to our chart here, Betelgeuse and the sun, we're here. Here's Betelgeuse right there. Get our maybe get like a red. Betelgeuse versus the sun. Okay. So we're going to go one by one and try to eliminate what we can. So it says, which statement correctly explains the difference in the elements composing the two stars? Okay, so we want to just go for any of them that say that the sun has a shorter life than Betelgeuse, we could just automatically get rid of, and then we'll go back and figure out the rest. So in Betelgeuse, helium is fused into heavier elements. I mean, that's true because it's an older star. And Betelgeuse has a shorter lifespan than the sun. So this is possible. In Betelgeuse, hydrogen has yet to be fused. That's wrong because this is already at helium. And if we know from our reference table, if we go to nucleosynthesis, it goes hydrogen, helium, carbon, oxygen, silicon. So if Betelgeuse is already at helium, it has fused hydrogen. So this is wrong. In the sun, heavier elements have completely fused into helium. No. See, the sun still has hydrogen, so that's wrong. And then in the sun, hydrogen has yet to be fused from heavier elements. That's wrong because it starts as hydrogen, so that's wrong. So that was pretty easy, honestly. So I would say this is honestly like a 2 out of 10 difficulty. Pretty easy question. Explain how the masses of Betelgeuse and the sun are a factor in the rate of nucleosynthesis being different for each star. So basically for this, there's nowhere, you're going to have to know a lot of background knowledge for this about stars. So it says, explain how the masses of Betelgeuse and the sun are a factor in the rate. So basically, rate is speed. So the idea here is that all you have to know is the bigger the mass, the faster that nucleosynthesis is going to happen because the lifetime of the star is shorter if it's high mass. So that's something that you just kind of have to know. So we're going to say, let's see, we'll keep it easy. We'll say the greater the mass, the faster the rate of nucleosynthesis. That's all you have to say. So, I mean, that's really easy if you know stars. So I would say based on, for me, to me, that's like a 2. Not even. Yeah, I guess a 2. But I guess if you didn't know that background knowledge, there would be no way to get it. So we'll just say, we'll call this a 4 out of 10 just for that. But it's really an easy question. All right, let's see what this next thing is. So we got our highlighter ready to go. We're going 6 through 9 on the information above. So here we go. Rubber ducks. Oh, trash. Okay, so you know what I'm doing? I'm just kind of looking at what it's showing me first on this one. Just a glance. And then I'm going to go down here. This is another strategy you can use. Some people like to go glance at the questions first. I kind of do it at the same time. So we'll see. I think I'm just looking around. So I'm going to read first. You know, these tests are long, so you could change it up if you want. So on January 10th, the container ship Ever Laurel lost 12 40-foot containers during a storm. One container broke open and released over 28,000 plastic bath toys. I kind of like to highlight numbers. You never know. These bath toys floated on the ocean surface for years and made landfall on the beach. The Pacific Ocean is home to the Great Pacific Garbage Patch. The island of plastic is 1.6 million square kilometers in size, which is 11 times the size of New York State. Garbage patches are found worldwide within ocean gyres where water conditions are calm. Now I'm just going to stop right here. Whenever I see anything to do with surface ocean currents, you want to go to page 20 on the reference table, which is the back of it. So it's probably going to ask us about this, but we'll see. Where were we? Plastic pieces in the patch. Okay. the size, composition, and age of the plastic pieces to determine the origin of the plastic in order to mitigate the problem of increasing plastic pollution in ocean ecosystems. So basically, they're just studying it to kind of help the problem. They don't want it to be increasing. The map below contains some information about it. So really, honestly, nothing much in that paragraph besides a little background knowledge. There's nothing, I don't think they're going to ask about that. But we'll see. So look, North Pacific Gyre. So basically, we're right over here. Like right in this zone. Okay. That's the North Pacific. It's to the west of North America. So technically it's also here. Okay. Let's see what it has to say here. Complete each of the three statements by placing an X to correctly describe the fact. Okay. Describe the factor responsible for the global atmospheric and ocean circulation patterns. Okay. So I'm not looking at this. So basically, anything to do with atmospheric and ocean circulation patterns, there's going to be a couple things. We got density, that's for the atmospheric patterns. Wind is going to move the water, and then like surrounding land is going to change the direction. Because obviously, if this is going this way, right, but we hit land, it's got to divert based on the land. It's either going to go that way or that way because the land is blocking it, right? So let's see. Evidence for the distribution pattern of the plastic bat toys from the accident location to the northwest coast. Okay, so see exactly what we thought. So, whoops. I don't want to highlight all that. So we're going to say the northwest coast of North America. So we're just going to go here and we're going to look. Look, northwest coast, that's the Alaska current. Let's see, the movement of the toys along the Kuroshio current followed by California. So Kuroshio here to California is there. So that's not right. So it's obviously the Alaska one. So we got, that's easy. And then one cause of the pattern is the ocean currents is, okay, so look, we said land. So that could work. Distance from the equator is not going to affect the global circulation patterns. It's location and distribution of land masses that's going to really be the deciding factor for that one. And then other than the ocean currents, global patterns that contributed to the distribution of the toys were also influenced by atmospheric. Look, boom. I swear I didn't predict that. I didn't even know that was there, I swear. Density, because anything to do with the atmosphere, the air is going to rise because it's less dense, and then sink because it's more dense, and that makes these convection cells, and that drives atmospheric circulation. Anything to do with like circulation is going to be density. See, that was my hint there. So I would say that one, honestly, pretty easy. I would say that's another 4 out of 10. So far, no really crazy questions. Other than the ocean, what factor also determines the global circulation of the... Oh my gosh. Boom. Look at this. I swear I didn't... That is literally the 3 things. Right? So the wind. The wind changes the ocean currents. So that's so important. So 2, that was so easy. So this was a 2 out of 10. That's a nice cluster. We like that cluster. All right. Many types of plastic are found in the Earth's ocean, so that we're still kind of going on this. The pie charts and infographics show some information about plastic. Arrows represent the transfer of plastic through different organisms. So now we're animals eating things. This is GPGP, I'm assuming Great Pacific Garbage Patch, so we're still in the same cluster here. Okay. Relative mass, so the masses, and then the quantity. Okay, fine. Transfer of plastics through marine food chain to humans, so we're going plastic breakdown into microplastics. So we got that, and then planktons ingest it, and then it accumulates in fish and humans. Okay, great. And then that's the idea. So the planktons ingest the microplastics, and then the fish eat the plankton. Birds and turtles feed directly at the surface of the patch. Okay. Sea turtles often feed on plastic bags and plastic sheets. This is because the turtles mistake the plastic for their common prey, jellyfish. That's sad. Which statement explains how the removal... Okay, so which statement explains how the removal of plastic bags will stabilize biodiversity in the area? Well, if we take the plastic bags away, then the turtles won't die. So, but now they're asking for jellyfish. So basically, it's saying the jellyfish will be eaten more because now the turtles aren't dying from the plastic. So we're going to have less jellyfish and more turtles. Right? Decreasing the number of bags will cause jellyfish population to increase. Nope. Decreasing the number of bags will cause the turtle population to go up. Yes, because the turtles will eat. That's not why. It's not because the turtles will eat more jellyfish. It's because the turtles won't die from the plastic bag. Decreasing the number of bags will cause the jellyfish population to decrease because the turtles will eat less jellyfish. No. Decreasing the number of bags will cause the turtle population to decrease. I mean, okay, this is really poorly worded, but 8 is 2. Decreasing the number will cause the turtle population to increase because the turtles will eat more jellyfish. Yeah, sure. I mean, I guess that's fine. That's fine. This was so easy. That's like literally a 1 out of 10. If you know how to read, you're going to get that right. All right. Many organizations and what do we got? Governmental bodies have ingested methods to address the growing problem of plastic pollution. Okay, these methods include reducing the use of plastics. Okay, reducing the use, recycling, and participating in waterway cleanups. Okay, great. Complex solutions in rivers, barriers, funnel the plastic into a collection area where the plastic is manually removed and hauled away to be recycled. In the oceans, the scientists use a device to collect floating plastic, bring it back to the shore for recycling. The photograph shows some information about these. Okay. It's like a big barrier, like a funnel, and then they funnel it into this plastic collection thing. Okay. And then ocean removal, a giant C-shaped tube aims to collect half the debris in the patch in 5 years. Make sure you're going in order 1 to 2. So we're just going to go like the tube, and then driven by wind and waves, the floating barrier moves with the plastic and other garbage. Okay. So the barrier moves. 3-meter deep skirt allows marine life to pass underneath. That's interesting. Okay. A sea anchor slows the barrier down. Garbage catches up and is captured. So basically, if they didn't have the sea anchor, the barrier would float at the same speed as the ocean, which is not good. So they had to do something about slowing it down. Every few weeks, you collect. And then we recycle. Okay. Oh my gosh. Honestly, I'm not even reading this. I'm going to come back up to this when they ask a question about it. A student, this is so much reading. A student makes a claim that the river cleanup method is a more effective, so we're going to say the river cleanup method is a more effective design solution than the ocean cleanup method for reducing the impact. Using all the information, which statement provides the most correct evidence to support the claim? You know, of course, I do have to read this now. Oh my gosh. And you know what? To just remember, so what I'm going to do is I'm going to just read the first sentence and see if it's right or wrong based on the reading it here. So ready? The river method costs less. Let's just start that. River. Let's see. Costs less, costs less. Look, lower cost. We're good so far. Then the ocean method and captures plastic before it enters the ocean. Let's see. Captures occurs before it enters the ocean. Look, that's good. We're good so far. Protecting river and ocean coastline biodiversity. So this is probably good. We'll keep going. The river method can collect plastic over a larger area. Look, this is over a large area. Look, automatically wrong. I could just stop reading. I don't have time to finish reading that. The river method is able to capture plastics of all sizes that are floating and underwater. No, because look, this is good at surface plastics. Not effective for deep plastics, so this is wrong. The river method captures more plastic than ocean because more plastics are found in the ocean. That's just backward sentence. The river method captures more plastic because More plastic is found in the ocean? Doesn't even make any sense. Okay, well, there we go. I mean, that question was so easy, but so annoying because it's a lot of reading, but I'm gonna do a 2 out of 10 just because of the amount of reading. All right. We made it. We made it to the next cluster. Okay, base your answers to 10 through 13. Evolution. Around 2.7. Okay, automatically, I'm going to my geographic history chart because it's starting to throw dates at us and stuff like that. So let's see what it has to say. So we got 2.7 billion years ago, microbes called cyanobacteria that formed stromatolites evolved in the oceans. These microbes perform photosynthesis. They had the ability to use water as a fuel to make oxygen. This oxygen was released into the seawater. Okay, its level gradually increased over 200 to 300 million years. Eventually, it escaped into the atmosphere. We'll just say they made oxygen, where it reacted with methane. This reaction causes methane levels to decrease and oxygen levels to increase. This occurred about 2.4 to 2.1 billion years ago. This increase in atmospheric oxygen is called the Great Oxidation event, and these oxygen changes on Earth indirectly led to climate change. Okay. The models will represent the different amounts absorbed and things like that. So before event, we got that, but some is escaping. During event, so this looks to me like there's energy reaching the Earth. Energy reflected is 2 arrows, and then there's 4 in here. And then in here, there's 2 being absorbed by the atmosphere, and then 4 now being reflected. So that was the switch. So now there's going to be more reflected and less absorbed by the atmosphere. Which row correctly describes the evidence for the coevolution of Earth's system as a result of the Great Oxidation event? Okay, coevolution just means that the things are evolving at the same time. So like the basically the creatures on the planet change the atmosphere, which then change the creatures at the same time. Something like that. It's just evolving at the same time. So let's see. Great oxidation event. Methane level decrease, oxygen up. I think they said that was the case. Yeah. It literally says that right here. So we're good with that one. So watch how I do this. So this one's wrong, and this one's wrong. So now we're between 1 and 4, just based on the first column. Less energy absorbed by the atmosphere. That's true. More energy absorbed by the atmosphere. Wrong. It's automatically 1. But let's just, led to earliest ice age due to increased reflection. Did they say that, I think? Look, oxygen level change led to climate change. It's probably right. Let's just see what the last one was. Led to earliest ice age due to decreased reflection. No, decreased reflection would mean there's more energy coming in, so that would heat up the planet. So this is wrong. So 10 would be number 1. Honestly, this was pretty easy again. There was nothing in there that was hard to do. 2 out of 10. Easy peasy. And more reading. Here we go. The Huronian ice ages were 3 separate glacial events that occurred. Okay. At that time, earliest ice ages. Okay. The planet's surface was almost entirely frozen. The supergroup is a group of geologic formations 12 kilometers thick. These formations provide evidence of the first major glacial episode. The age of these formations was determined using the ratio of uranium to lead isotopes. Okay, so now they threw isotopes at us. So if I would just be like, okay, get ready for our radioactive decay chart right here. So we got uranium, and I already forgot what they said, but something like that. So we're gonna uranium to lead. So that's either here or here. Okay. The Huronian supergroup is typical of deposits in a marine environment. It consists of sedimentary rock. So I'm just going to say marine environment. That includes drop stones, which is embedded volcanic and sedimentary fragments. Okay. Drop stones are evidence for glacial ice ages because glaciers carry different sized sediments in the ice. Glaciers then drop these rocks at sea. They become embedded in marine sediment and eventually form sedimentary rock. Okay, that was a lot of information. All right, which statement identifies the evidence used to determine when the Huronian Ice Age occurred? Radioactive dating. Um, yeah. The age of these formations was determined using this ratio. So it probably has something to do with that. Index fossils, they did not say anything about fossils. It was radioactive decay. Rocks in the supergroup were carbon dated. No, because it wasn't using carbon. And then the ages of the dropstones go away. In the sedimentary rock are younger than the particles that make up the rock itself. The ages of the dropstone in the sedimentary rock are younger. No, because they eventually formed the sedimentary rock, so that's wrong. So this is 1. Listen, this question was so easy as long as you know what radioactive decay is. So I'm going to say this is a 2, but I'm going to give it a +1 because of this annoying reading. This was a lot of reading. I might actually give it 2 more. I'm going to say this is a 4. But the answer was 1. All right, among the oldest rocks on Earth are sedimentary rocks known as banded iron formations. These rocks formed in oceans containing some of the Earth's first available free oxygen. The model below shows some information about the Earth's early atmosphere and the oxygen. All geologic times are approximate. Billion years is there, blah, blah, blah. Okay. I'm just going to try to look at this and get an idea. So early ocean and atmosphere. Okay. Formation of Earth. They gave us the formation of Earth 4.6 billion years ago. Then the ocean formed. Then black smokers formed. So that's like little volcanoes. Okay. First evidence of life. First microfossils. Banded iron formations. Explosion of life. Mass extinction today. And we're saying basically at this spot, iron and ions, oxygen, stromatolites started there. And then it's saying overall, the iron went down and the oxygen in the atmosphere went up basically when the stromatolites were formed. Which statement correctly uses the information from the model as evidence to support the claim that during the end of the Huronian Ice Age, changes in the hydrosphere caused a change in the geosphere? Well, when stromatolites were formed, well, the geosphere, that's interesting. There's no microfossils that it mentioned, so I'm going to say that's wrong. Iron in the ocean was used for energy by the photosynthesizing stromatolites in the shallow part of the ocean. It seems like that's probably the case because once the stromatolites were there, the concentration of iron ions went down as the oxygen levels went up, unless they were reacting some way. I don't want to get rid of that one yet. The presence of CO2 and methane in the ocean led to the formation of black smokers. No. It doesn't say anything about CO2 and methane in the ocean that I saw. I'm going to X that one out. The presence of iron and oxygen in the ocean led to the formation of banded iron rock layers on the bottom of the ocean. That's right. So the thing about this one is it's asking specifically hydrosphere and the geosphere. The geosphere is more of the rock. So I'm going to say this is the exact answer that's going to affect the hydrosphere and the geosphere. Geosphere is like the rock layers, basically. So this is 4. I would say it's a little tricky. I'm going to call this a 4 out of 10 difficulty. But so far, I haven't seen anything crazy. But we're only on question 13. Earth's surface processes cause changes to Earth's surface and the atmosphere. Past changes produce conditions that led to future events. Okay, we're going to use the information provided to place the list of events below in the correct temporal sequence. So you know what that means? That means in time order. To complete the graphic organizer, and it wants oldest to youngest. So the oldest thing is obviously going to be the formation of the Earth. Oh, okay. Are we just literally reading the graph right here? Okay, oceans form is next. Wow, if this is the case, this is so easy. Okay. Okay, let's keep going. Then it's black smokers and then first evidence of life. Do we have those? Look, black smokers. You're going to write out the whole thing. I'm just going quick for the video. And then life. Banded iron is going to be next, and then the oxidation event. So that right there is the easiest question on the test. This is like a -1 out of 10. That is the easiest question on the test. I don't think it's going to get easier than that. You literally just copy the graph. That's a meatball question. Meatball question. All right, here we go. Base your answers to the questions 14 through 18 on the information below. Okay. We got mined and mineral resources of New York State. So maybe it might be a good idea to jump to that page. Look, energy and mineral resources of New York State. We might need that. We're investigating mined and mineral resources in New York on a trip to the Adirondacks to teach. Okay, so basically, look, Adirondacks, if you don't know where that is, right here, which means it's here. We're actually the New York State mineral. This mineral was an important sort of abrasive, okay? Student found several of these rocks on the trip. They recorded observations about the physical properties in order to identify these large minerals. Okay, so now we're on tricky. We're going back to the mineral ID chart, so maybe we're here. In order to identify these large minerals embedded in the rock, they took a photograph, which is shown. So we got these mineral crystals, okay. Observations. Okay, the mineral blah, 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 dark red, glassy looking. Okay, yeah, we're on the mineral chart. So let's just go dark red. Which set of observations and mineral name correctly identifies the crystal in the photograph? Well, we can't go colors. So these are the, okay, so dark red and glassy looking. The trick here is that it's only one of these, right? So let's go magnetite, olivine, garnet, hematite, and we're going to look to see if any of those are dark red and glassy. So magnetite, olivine, garnet. So, garnet, dark red, so that's good. Olivine, magnetite's black, so magnetite's out. So we're gonna go cross off magnetite. Garnet is possibly good still. But it could be these. Well, dark red, anything with A has to be dark red. So this is out. So now garnet is good. So this is good. So now we're going to see if B is hematite. The mineral crystals are embedded in a rock with several light and dark minerals mixed together. D, the rock was found at high elevation. And F, the rocks containing were very dense. So let's see if hematite tells us any of that. So hematite's here. Thin sheets, brittle, red-brown color, red-brown streak, but doesn't say anything to do with those things. So I'm going to cross off this one. There's no way to determine elevation based on that mineral ID chart. So, but we do know that it was in the Adirondack, so that's possibly correct. F, the rocks were very dense. It doesn't really say that. All right, let's keep going. Olivine, D, E, F. D is good. All of them were found. Well, this, high elevation, if it was found there, it was found there. E, the mineral crystals broke into uneven pieces with sharp edges. So let's go olivine and check that out. Olivine is right there. Green sand. No cleavage. It's sand. So I'm going to say that's probably not sharp edges. I don't really like that. A, C, and E. So Does garnet have a colorless streak? Yes, it does. And fracture, uneven pieces, and then F, does it have good density? It doesn't say density that I see, but it is a good hardness, so I'll call it dense. I'm going to say this is the best answer. And that was an annoying question. Honestly, I'd say this is like a 6 out of 10. It's just annoying, honestly. You're probably going to get it because the dark red kind of just automatically gives it away, but it was annoying and it required a lot of work. So I'm going to call it a 6. All right. Limestone and dolostone mines comprise the third largest number of mines in New York State. Primarily used as crushed stones in the construction industry. Okay, so now we might be back on that resources page. Does it say anything about crushed stone? Not really. Okay, let's see what it has to say. Major highways, okay. Okay, using evidence from the map, construct an explanation that describes how a human activity may have been affected by the availability of limestone and dolostone. So look, they built the highways at the same locations as the mines. Look at it. It's the same pattern. That. See? It's the same pattern. So, that makes sense. So we could say the highways were built based on the locations of the mines. We could say how a human activity may have been affected by the availability of limestone and dolostone. I mean, that sounds like it's right. It probably you could add to transport it. So it was like a convenience thing. So I think that was pretty easy. I'll say that's a 2 out of 10. Pretty easy. Don't mind my bad handwriting. Okay. Mines must be reclaimed when the mine is no longer in operation. This means that the environmental effects of the mine must be reversed, returning the land to a usable condition. Photographs show 2 stages of reclamation of the Woodburn Flats mine. Photograph 1 shows a portion of the Neversink River with 600 newly planted black willow trees. So basically, they're going to try to restore the area after we're done with it. Write the correct letters from the choices below on the line at the end of each sentence to complete each statement about the Woodburn mine flats. Okay, so we're just gonna... Okay, so we're just gonna write A or B for both of them based on what it says. Okay, ready? The planting of the black willow trees will stabilize the riverbanks, yes. Reduce the impact of flooding, probably because the trees are going to do a lot of absorbing of water. This says reduce deposition of sediment. No, there's going to be more deposition because we're going to stabilize the riverbank. So I'm going to say B. Okay. The creation of the pond will capture sediment stormwater to be used as a source for drinking water in a nearby housing complex. That sounds weird. Capture runoff from the area, reduce the amount of sediment released into the nearby river. It's definitely going to capture runoff. So we're going to go D. And then the planting of vegetation of the pond will stabilize slopes, yes. Restore habitat, sure. Introduce non-native plants, no. It's just going to restore the habitat. There we go. That one was fine. 3 out of 10, 4 out of 10. 4 out of 10 difficulty. Lots of 4s. All right, paved road surfaces are typically constructed from a mixture of aggregates, so sand, gravel, and crushed stone. It's held together by an emulsifier. An emulsifier is a sticky tar-like substance made from petroleum. Okay. Petroleum. Historically, natural sources like quarried stone were used for road construction. A newer method of road resurfacing called recycled asphalt pavement has been used on road resurfacing projects. Some differences between these two are described in the table below. Of course, why wouldn't they be described in the table below? Of course. Okay, here we go. Blah, blah, blah. Whatever. I'm literally not reading that. I'm just going to see what it has to say down here. Recycled asphalt paving model. This is crazy to me. Okay. Which statement below I didn't know we were taking a construction class. Which statement below correctly identifies a benefit to a local community when comparing these two design solutions? How about the local community says, I don't want to read this chart. Did I say that? Local quarries supplying natural paving materials will use more fuel for trucking. Let's see. Natural. So we got natural. They use, okay, by truck. And this one, that one doesn't require transportation. So that's true. Recycled asphalt pavement will use more petroleum products in the form of fuel. And where did we say that? The emulsifier. Yeah, see? But this is 1 to 3%, and this is 3 to 7%. So there's more in natural paving. So this is not true. Recycled pavement does not require reclamation. That can't be true. Everything should require reclamation at some point. Will extend the life of existing quarries. Oh, look, reclamation is not required. So this is possibly right. Will extend the life of existing quarries. Okay, maybe. Blasting, crushing, and processing costs are higher with recycled asphalt pavement. Does not require transportation. They grind stuff on site. It doesn't say anything about blasting. I don't see anything about blasting. I don't see that. I'm going to say that's probably not the case. So now I'm down between 1 and 3. Local quarries supplying the paving materials will use more fuel for trucking and processing. Recycled pavement doesn't require reclamation and will extend the lifespan of existing quarries. I'm going to say, based on the fact that I don't see that, local quarries will use more. Oh, that's where I was going wrong. Which one's a benefit to the community? This is not a benefit to the community because they're going to use more fuel. So even though it's true, it's not a benefit to the community. So I was going through seeing if they were true or false. So it's 3. I hated this question. I would say this is a 7.5 out of 10 annoying question. I hated it. It's annoying. All right, natural material is sometimes blended with RAP at asphalt plant. Okay, we got a blending ratio, percentage mixed with natural material, and we have some information about recycling. Which row? Okay, so basically the more the ratio is, the lower carbon emission. So meaning if this is higher, there's less of carbon, there's less carbon put into the air, which I guess they're going to assume is going to increase global warming. So if there's a higher ratio, then that will increase. No, so this is wrong. So we want an inverse relationship. So this is automatically wrong. So if we increase, then we're going to decrease carbon emission, which is decrease global warming. 3. This was very, very easy. 1 out of 10 question. All right. Yes, astronomy. All right. Let's see what we got on astronomy on this test. In addition to the 8 planets of our solar system consists of other celestial... I can't believe, is this the... I don't know. I just like astronomy stuff, I guess. We got dwarf planets discovered in 1930. Pluto is one of the largest In our solar system, we have 5 moons. Charon, half the size of Pluto. Maybe a double dwarf planet system. Okay. We got Pluto and Charon binary system. The orbit of Charon around Pluto is not shown. We're going to have to draw an orbit? Okay, complete the list of moons to rank the moons in order of increasing orbital period. Okay. Wow, they want us to know Kepler's laws. Cool. Okay. So let's see. So we know, we're just going to write the Kepler's laws right now. So just to go over Kepler's laws, right? Law number 1 is all planets travel in elliptical orbits. Law 2 is basically saying the closer to the planet equals faster speed. And then 3 is going to be what we're going to write. So increase distance from the main body is going to increase the orbital period. That's the one we're going to write. So we could say as distance from Pluto increases, orbital period, which is the time it takes to go around Pluto, increases. So that's all we're going to do. So here's your orbiting distances. And what does it want us to do? 1, 2, 3, 4, 5 of them. 1, 2, 3, 4, 5. They're not in order. So we're going to go, Charon's the number 1, because we're going to go shortest orbital period. So it's going to be Charon. Okay, number 2 is going to be Styx. The river Styx from mythology. 48,000 Nix. It might be Charon, by the way. These are all mythology things now that I just picked up. Kerberos, Kerberos. I don't know what figure that is. And then the last one's going to be Hydra, which is the 3-headed monster from like Hercules. So the Charon, Styx, Nix, Kerberos, Hydra, and we got our Kepler law. Cool. That was easy. We like that question, but if you didn't know Kepler's laws, it was hard, so I'm going to call it a 4 out of 10. Right down the middle, basically. Based on the information on Pluto's moon's data table, which row in the table correctly describes the speed of Styx and the gravitational force of attraction exerted on Styx by Pluto as it orbits Pluto? So another Kepler's law. So the gravitational force is going to change because it's an elliptical orbit. So it's not going to be constant. So we want to get rid of 1 and 2. And the speed is not going to be constant either because as it gets closer, it's going to go faster, so on and so forth. So it's going to be 4. This was so easy. 1 out of 10. Kepler question. Easy, easy, easy. All right. The model below shows some information about the orbit of Pluto around the sun. Trying to figure out. So Charon looks like it's a crazy. Is that true? Like orbiting axial tilt. That's not going to matter. It doesn't tell me orbital direction on this one. Oh, sorry, sidetracked. Okay, the data table below shows some information about Pluto and Charon. Okay, we got those. So it looks like Pluto, orbital period 90,000 Earth days, and Charon takes 6.4 Earth days to go around Pluto. Which pieces of evidence shown in the model and the data table support the claim that the phases of Charon change cyclically? Okay, so we're just getting the facts here. Pluto orbits the sun every 90,560 Earth days. Charon orbits the sun every 90,000 Earth days. Wait a second. Orbital period of Charon is around Pluto. Charon orbits Pluto. Yes, that's what we want. Because we want Charon to orbit Pluto. Basically, they're trying to mirror the moon phases. Charon orbits the sun every 6.4 Earth days. That's definitely not true. So basically, you know, if you think of the moon, right? So if this is the Earth and the moon goes around the Earth. That's what caused the phases of the moon. So if we want the phases of Charon, we want Charon to go around Pluto. And that takes 6.4 Earth days, which is actually really fast. Charon orbits Pluto every 6.4 Earth days. That was a little tricky, I'm not going to lie. I'm going to say this is a 6 out of 10 question. It's a little tricky. And this diagram is tricky. Let's keep going. Student makes the following claim: the same side of Charon always faces Pluto to observe on Pluto, just like the same side of the moon always faces the observer. The only way this is possible if the moon's period of rotation is equal to the moon's period of revolution. So it would have to revolve at the same time it rotated. Now, Pluto's axis of rotation is there and there. Oh, look. Rotation and orbital period. It's the same. That's crazy. I didn't know that. So this is a support because Charon period of rotation is equal to its period of revolution. That is cool. I did not know that about this. So we're good. Some good pictures. Charon was first discovered in 1970. I think it's Charon. Now that I mention it. That's how you say it in mythology. Charon. Whatever. The 4 smaller moons were discovered between 2005 and 2012 using the Space Telescope. Some researchers have suggested that all 5 moons could be debris from the impact. Others theorize that 4 smaller moons was created from an impact with Charon. Okay, so maybe it was either something hit Pluto or something hit Charon. Which statement would provide evidence for the formation of Pluto's 4 smaller moons from a possible impact with Pluto or Charon? Well, if they have the same composition on them, that would be a good one. Pluto's surface is coated with ice. I don't think that would matter. I'm going to say that's probably... Craters with a diameter as large as 240 kilometers exist on Charon's surface. Does it say size here? Going all the way back up here to get these? But it doesn't tell us anything about 240 kilometers. Oh, diameter, 2,000. I don't know why that would help us. Is on Charon's surface? I just see something. The 4 smaller moons spin more rapidly. That doesn't matter. Both Pluto and Charon have ice volcanoes created from the buckling of subsurface ice. Some researchers have suggested that all 5 moons could be debris from the impact of an object with Pluto, but the 4 smaller moons was created from an impact with Charon. I mean, that could possibly be true because then giant things hit Charon. There's nothing to do with methane ice. The spinning is not true, and both Pluto and Charon have ice volcanoes created from the buckling of subsurface ice because they're getting impact. It's just weird. Both Pluto and Charon have ice volcanoes created from the buckling of ice. That's not going to provide us with impacts, though. Buckling of ice, that could be from like tectonics, it could be from melting, so I'm going to actually get rid of that one. This is the only one that it could be. Craters with diameters of this exist on Charon's surface. Oh, it says Pluto or Charon. This question's terrible. I'm going to go with 2 as the best answer, but I think this is a bad question. Who wrote this? I don't know. Listen, this is like a 7 out of 10 question, but I don't like it. I'm going to say thumbs down. I don't like that question. 23. It's really weird, and I guess they're just going for an impact. The only thing there that is going to be proof of an impact is 2. Maybe I overthought it. Now that I'm thinking about it again. All right. I take it back. I take this all back. I think I overthought it. Because the only thing that's impact event is the crater. So I'm actually going to call this, for a kid, it's probably another 4, and I'm going to say fine for the writer. It was fine. All right, moving on. We got Doggerland. Doggerland was an area of occupied ancient humans. Glaciers once covered the area but melted. Okay, so occupied by ancient humans. Glaciers once covered the area but melted between 20,000 and 9,000 years before present. So we melted. Doggerland connected present-day France to England. Just looking at this map because I'm interested. Doggerland's here. It was just an ice sheet? So now obviously it can't get through. I mean, you can't cross. Which summarizes the climate change that most likely occurred at Ireland over the last 18,000 years? Well, obviously temperatures went up. So we need to melt a glacier. So, oh, now we're on currents. So let's just say we definitely want temperatures to increase. So we don't want temperatures to decrease. We don't want temperatures to decrease. So was it because of so we're going to go there, near Dublin, Ireland. So right there, Atlantic Ocean. We're going to go find out what river that is. I mean, what ocean current that is. So right here. So it looks like the Norwegian current. But that's not an answer that we have. So we're going to have to go with North Atlantic, which is right there. So it's right here, North Atlantic current. So that one would be the right answer. This question was real easy. As long as you know we want to melt the glacier, and then you go to that surface ocean current chart, then that would be pretty easy. So we're going to say this is a 3. The underwater Storega landslide also affected the Doggerland region. The map below shows some information about the Storega slide and the associated tsunami that occurred 8,200 years ago. Okay. So this is just a graph that shows how high above sea level the tsunami was in all the locations. Okay. What do we got here? Tsunami deposits. So basically, after the tsunami was over, it dropped off sediment. It's a giant picture. Which row complete the passage? Okay. The tsunami was a destructive. So process. The coastline would have experienced a lot of erosion. Yeah, because it's going to destroy the coast. The location of sea experienced less impact from the tsunami. So let's see if Amelsto was 3 meters. Amelsto, 3 meters. Yep. So that is going to be 3. That question was so easy. I would call this a 2 out of 10. Really easy. We're going to understand. I figured this was coming. Which claims are supported to be correct from the data collected? Marine gastropods are the oldest remains, so that's going to be the lowest on the bottom. So let's see, marine gastropods. Yeah, they're the oldest. So depth below. So marine gastropods are the oldest, so 1 is good. The tsunami deposits contain the largest size sediments. So let's see, does it say sediment size? Yeah, so sediment size is going to be gravel. So it looks like this layer is going to be stuck out there, tsunami deposits, so that's true. That's true. Peat and soil clasts are only found at 640. So let's see, 640. No, because peat class and soil class are at 680, so that's wrong. Twigs, leaves, and moss in these deposits contain more than 75% of their original carbon-14. That is so annoying because now we got to go. That is cruel. 75% of carbon-14, if the half-life is 5,700 years, to get 70, so to cut it in half is 5,730 years. So figure they have to be, but it's weird because it's not, so just they have to be less than 5,730 years old. Twigs, leaves, and moss. But it can't be true because this happened 8,200 years ago, so that's wrong. It would be less than 50%. So that's wrong. The sediments and organic material at the 600 centimeter depth are most likely freshwater deposits. Let's go check. Leaf and moss. I mean, maybe. Probably. Fresh water. It's from a glacier. Right? Oh no, this is from a tsunami. Maybe? Leaves and moss. So that sounds like it could be fresh water. Let's just say that might be true. So it's definitely 1, 2, 5. 1, 2, 5. Yeah. Because 1 and 2 and 3 is wrong, and that just narrows that down. So this was a reading question, and looking at the chart, it was honestly a 3 out of 10. It was not that bad. Okay, since 1994, we're still in Doggerland. A high-speed Eurostar train uses the Channel Tunnel to carry 11 million travelers under the channel every year, so they got an underwater tunnel there. Prior to that, they relied mostly on airplanes and ferries. And then they're basically showing, look, this is so much cleaner energy than this one. Identify the Earth systems that being impacted the least by the Eurostar train. Okay, well, this is carbon release, so it's going to be the atmosphere. The atmosphere is the least. And then use numerical evidence, so we got to use numbers, how this solution reduces the impact. So we could say airplanes released 255 grams per kilometer of carbon, while Eurostar is only 6 grams per kilometer. Easy. That was a 2 out of 10 question. Easy. All right, next section says base your answers on the Greenland's glacial ice section here. So it says the Greenland ice sheet is a large portion of ice that covers about 80% of the landmass. This ice is a significant portion of Earth's freshwater storage and plays an important role in Earth's climate. For this reason, scientists have been studying how this ice sheet has been changing. Okay, so we got our ice sheet, and there's some latitude and longitude numbers on here. We got some thickness of the ice, so we could see this is going to be the thickest, towards the middle, it seems like. Yeah, and then there's a key here with some distances, so we'll see what we have to do. Based on the map, which evidence-based claims correctly identifies how a change in climate most likely affected the current pattern of ice thickness? So it seems like exposed land is here, so it's melting out here. It's melting around the outside because that's exposed land, and then it's thin here, and then it's getting thicker and thicker and thicker as you go towards the middle. And that's happening from outside to in. So let's see. So obviously we're going to need to melt, right? So we're going to not do like a cooling climate. Well, cooling of climate in polar regions cause no ice and more exposed land. No, because exposed land happens when all the ice melts, then the land is exposed. So that's out. A warmer climate at lower elevations cause ice to be the thickest near the center of Greenland, where it's over 3,000 meters and thins to 0. So the center over here is over 3,000 meters. And then the outside would be 0. This is possibly right. Cold climates cause ice ranges from 0 meters at the edge to over 2,500 near the GISP-2 drill location. Okay, I mean, technically it's right, but that's not going to be cold climates. And then we got a warming climate produce no ice thickness pattern. That's wrong. So 28, the answer for this one is 2, and this is a nice and easy question. I would call this like a 2 out of 10, basically. Pretty easy. All right, we got a graph, and it's showing the change in ice mass, and you could see, there's less ice mass going down over time. Using the information in the graph, make a claim that describes a feedback that occurs as the result of change in ice mass. Wow. Okay. So basically, I would say for this test, you should definitely know a couple of feedback loops just in your arsenal. I mean, at least have 2 of them. The ice melt one is definitely a good one to know, and it's going to pay off right now because I happen to know that one. So I would be like, as temperatures increase, ice melt increase, right? That exposes darker water and land, which then heats more and melts more ice. That's the one that I like. You could also go like a route of water, you know, this is going to release fresh water and that's going to dump into the oceans, which is going to make sea level rise. That's a good one. You could say if fresh water is melting, then the salinity of the ocean around it's going to go down. So there's a couple you could do, but this is a feedback. Oh, but it does say that cause a change to Earth's oceans. Okay, so really, like, my answer is not that great. So we gotta add how that changes the oceans. So we could keep it and be like, so sea level rises. I almost missed that last part there. So yeah, that's my so that was pretty easy, honestly. 3 out of 10 on that one. But here's a good, you know, sometimes I jump the gun and I kind of know what it's asking. You really got to read the whole thing to make sure you know exactly what it's asking before you just start to answer the question, or you make a mistake like me. If I left this part out, because I read it again afterwards, if I left that out, I probably might not get that right, because I didn't say how it caused the oceans to change. I just did a feedback about ice melting. All right, based on the trend shown in the graph, which claim correctly describes the rate of change from 2010 to 2022. So they want me to do some math here. So rate of change is going to be change in value over time. So they want it from 2022 to 2010. So that is going to be 12 years. And we need to change the value, change in value from 2022 to 2010. So we're just going to go here. 2022, it's like negative 5,800. So negative 5,800 to 2010, which is about negative 3,000. So that's a 2,800 change. So it lost 2,800 over 12 years, and then you would divide that, and hopefully you would get an answer that is close. I'm just throwing it in my calculator here. 233 loss per year. So it's not over 12 years, because in 12 years it lost 2,800. So far this one's probably closest. The rate of change in ice mass loss was less from 2010 to 2022 than it was in the previous 12-year span. No, that's not true, because it plateaued in the beginning. It's like a flat line. And then it's saying was 3,000 per year. No, that's wrong. So it's going to be 1. And you know, you would just pick the closest one, because your math is, especially when you go quick like me, you can actually use like your reference table to line it up and get a straight line. You probably get a more accurate answer. Okay, next one. The model below shows some information about albedo. So albedo, if you don't know what that means reflectivity. So reflectivity. So that's basically how reflective the light is off a surface. This is the effect of different types of surfaces on the ability to reflect. Oh, so I told you what it was. Great. If sea ice reflects 60%, so sea ice 60%, then the 40% that's left over is absorbed. Okay. Using the information in both the model and the graph, write the correct letter from the choices below. on the blank to complete each statement about the albedo effect. Okay. Let's just read and we'll go check. Using the maximum values in the model compared to bare ice melting on the Greenland ice sheet, as more soil is exposed, approximately blank is absorbed by the exposed ground. And we got 20, 60, or 80. As more soil is exposed. Well, if it's 20, 60, or 80, it's going to be 20. So this one's going to be A. Okay. Statement 2. More exposed ground on Greenland's landmass will result in an increased energy. So if there's more ground, then it's going to absorb more heat. So there's going to be more energy flow into the surface. Yeah, because it's going to be less reflected. So there's going to be more energy going into the Earth's surface. D. The resulting effect will be you're going to warm. Cause regional and global cooling? No. Cause regional warming and cause sea level change? Yeah, probably. To maintain the current climate. So it's going to be H. Listen, let me give you guys a hint here. These tests are so geared towards global warming. Basically saying something's heating up the Earth and that's going to cause the climate to warm. So, like, if you were to know anything, like, that is such a point that they're driving home on these tests that you could probably get so many questions right just if you understand that that's what they're testing you on. So, like, basically, everywhere the climate's getting warmer. Generally, that's what they're asking about. So, basically, if you had to guess, I guess something like that. Okay. I wonder if I wrote global warming for every single answer on the whole test, what my score would be. The model below shows some information about ocean current circulation. Okay. The graph below shows information about some seawater characteristics. Salinity is measured in number of gram per salt. Okay, so just seawater stuff and the way that the water is moving. So we're moving, warm water, cooling, sinking. So it's a convection current. So this is called convection, when warm air rising cold, or warm water rising cold is sinking. So this is convection. It's based on density. So less dense up here, more dense down here. I'm just writing things that are in my head. Okay, so we got, oh look, seawater density and temperature. So salinity, density, okay, I don't know what this means yet. We're going to go look at the question. Based on the model and graph, which model correctly summarized changes to an Earth system off the coast of Greenland? Oh my gosh. This is a mind-blowing brain meltdown of stuff here. Okay, let's just see what's different in them. So I'm just going to kind of gauge this. So north-south, melting increases and rainfall decreases. Warm water can't move north and sinks. More fresh water increases salinity and increases density. Okay, let's just see. So this is saying the density is higher. Density is higher with the salt. Density is low with fresh. So I'm going to write that here just so I can remind myself. So fresh water is lower density and salty is high density. Just so we have that here as we look. So let's see. More fresh water increases salinity. That makes no sense. Less fresh water increases salinity. Yes. And if there's more salt, it's more dense. So that statement is right. I'm just going to look at those bottom statements and see if I can just solve the problem. Less fresh water decreases salinity. No. More fresh water decreases salinity. Yes. And decreases density. So does more fresh water decrease density? Yes. So now we're between 3 and 4. Now let's see what else is here. Melting ink. So now look, this is weird. The cloud is raining a little bit, but now it's a lot of rain here. Melting decreases and rainfall decreases. Okay. melting increases and rainfall increases. So again, I'm going for climate warming, right? So if there's warming, melting's going to increase. And rainfall is going to increase because we're going to have more evaporation and stuff like that. Warm water rises but can't move north because it's being blocked. I'm leaning towards this one. I'm just going to go check to see if there's anything else here. Is this still part of this cluster? It seems like it. Yeah. So 32, I'm going to go with this one because more melting is going to be from warming. So if the area is being warmer, which it is, you're not going to have decreased melting. So that makes that one wrong. This question was so annoying. I would say so far, this is probably the hardest question. I'm making myself the brain of a kid, right? Taking this class. That's very hard. Okay. Base your answers to the thing below. Okay, Bennu. Bennu is a small asteroid with the age of approximately 4.6 billion years. Okay, so right away I know this is the age of the Earth. Age of the Earth. About. Bennu currently orbits the Sun at a mean distance of approximately 1.1 AU, okay? 1 astronomical unit is equal to the mean distance between the Earth and the Sun. So it's pretty close to the same distance away as the Earth is. Bennu's orbit is tilted 5 degrees. Okay, that's kind of like the moon. In 2016, NASA sent the OSIRIS spacecraft to study this. This asteroid's surface was mapped in 2018, and the sample of the material was collected in 2020 and returned to the Earth in 2023. Okay. Initial studies of the sample suggest Bennu's original source contained... Okay, so let's highlight this. Water, ice, and carbon monoxide ice. Carbon monoxide ice forms at approximately 4,500 million kilometers, 30 AU from the Sun. So basically, you can conclude there that if there was this carbon monoxide ice, that this asteroid is moving closer to us. Because it would have had to been this far away at some point, 30 AU away, and now it's 1.1 AU. So it's drifting closer and closer and closer. The orbit moved. That's just my guess right now. So a student want to identify the math and computational information needed to determine when this OSIRIS could land on Bennu. Which table correctly lists the period of revolution and mean distance data needed to predict when OSIRIS will cross Bennu's orbit? All right, what am I missing here? So OSIRIS starts to orbit there. We launch. So basically right here, we're going to cross. There's 3 paths here. There's the solid gray line, which is Bennu. There is the Earth's path, which is black, and then the OSIRIS one, which is the dot. Oh, this stinks. All right, let's just see. Earth's period of revolution, 365.26. So yeah, if you didn't know that, you can go on this chart here and you can get it. So Earth, right there, 365.26. So this is correct. And unfortunately, that is right on all of them. So that's good. Now we're just going to go down. Earth's mean distance from the Sun. Look, it's 149.6 on all of them, so that won't help us. Okay, Bennu's period of revolution. It's further from Earth. So it has to be, it cannot be the same. It can't be the same. It has to be more. Because it's further from the Earth. I mean, it's further from the Sun than the Earth. So this is not right. So I'm automatically going that this is probably right, but we'll keep checking. The mean distance from the Sun is going to be a little further than Earth's mean distance from the Sun. So again, 149.6, it's... I'm still leaning towards 2 for some reason. This is much further. Let's reread the question here. We list the period of revolution and mean distance data needed to predict when the OSIRIS will cross Bennu's orbit, allowing it to land on Bennu. So this one's out. The mean distance from the Sun is going to be, will cross Bennu's orbit. So that would be here. and then the mean distance from the sun cannot be the same as the Earth because it's further away. So this one is actually eliminated now too. So now we're between period of revolution being 436 and the mean distance from the sun being 300 million. That would literally be... I had to reload my reference table in my test here. So we're basically between Bennu's orbit revolution being 436.65 and 169 million kilometers away from the sun versus 299 million kilometers away from the sun. But if you look at here, 299 million kilometers away from the sun would be Mars. Now you're out by Mars, which can't be true because that's way too far away. So I'm going to say this one's out. So based on this number here being way too far, 3 is the best answer. This is now my new, this was the hardest question so far, I think. This was, like, for a kid to solve this, it's so, like, this is like a 9 out of 10 difficulty. But 33, so far, like, that and that last question were brutal. All right. Which statement provides evidence about the formation and movement of Bennu through the solar system? Okay. Now, we said Bennu, if 4,500 million kilometers, it had to exist out there. So if we go to there, look, that's out by Neptune. 4,500. That means it started by Neptune. So let's look. Bennu formed near the orbit of Saturn and then moved closer to Neptune. No, it's coming towards us. So Bennu formed inside the Earth's orbit. No, that's closer to the sun. Bennu formed in the asteroid belt. No, because that's between Mars and Jupiter, so that can't be right. Bennu formed near the orbit of Neptune and then moved close to the Earth. Yeah, 34 is 4. So it's so funny because this question's so easy. So this question's like a 2 out of 10. Like, that is really easy. So, I mean, they need to split these down the middle, like make a medium question for both of them, not something impossible. All right. Scientists have calculated there's a slight chance that Bennu could collide with Earth. Okay, in 2182. I'm not going to be here by then. The potential for an impact between this has prompted studies to prevent it. Okay, so we got prevented. So kinetic impactor. This option is a program called the Double Asteroid Redirection Test. NASA carried out the experiment by striking Dimorphos with a small spacecraft at a speed of 6.6 kilometers per second. It just changed the speed and trajectory of that asteroid. Great. Second option is to launch a nuke and have it explode near it. The force of the explosion could alter the path. Third option is the Yarkovsky effect. I've never heard of this. This is a naturally occurring phenomenon on small asteroids. It happens when the sun's radiation strikes the object, okay, as it spins on its axis, changing in orbit over time. Scientists could increase this by planting or placing foil on the surface. How much foil would you need? Based on the cyclic motions of Bennu and Earth, describe the conditions that are necessary for Bennu to collide with the Earth. The conditions necessary based on the cyclic motion? I don't know what they're going for here. Describe the conditions that are necessary. You need them to cross paths. Cyclic motions. Okay, so that's rotation and revolution. That's what cyclic motions are. So we're just going to say we're going to mention rotation and revolution somehow. We'll say the revolution of the Earth has to be the revolution of Bennu around the sun has to align with Earth's revolution. The revolutions, I mean, that's literally of Earth. Bennu must align. Yeah, I mean, okay, like, that is stupid question. Like, what did they just run out of questions to ask? 3 out of 10? It's stupid. I don't know. I don't get that. I don't know. Okay. Which statement describes why the speed of the DART spacecraft changed before it impacted? Why did the speed change? Blah, 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 blah. Okay, let's see. Well, let's see which statements are right or wrong. Its speed increased due to the sun's gravitational pull. Probably not. The sun's far away, so I'm going to say that's probably wrong. Its speed increases due to dimorphous gravitational pull. That's possible, because as it approaches the asteroid or whatever it is, that would change it. The speed decreased due to Earth's gravitational pull. The problem is, how am I supposed to know if it increased or decreased? And then the speed decreased due to dimorphous gravitational. I would say it's 2, because you got your little rocket ship and you got your asteroid, and as they come closer to each other, this thing's gonna start pulling pulling it towards it. So I'm gonna say 2. But this again, like, this question is weird. 4 out of 10, weird. I don't like these last like 4 questions so far. I think they're all bad. All right, place 1 check mark in each row to identify the option 1 and 2 or option 3. 1 and 2 that meets the criteria and constraints listed into the table. Occurs continuously. Okay, a nuclear bomb is not going to be continuously, so this one. Solar radiation, that's always happening, so that's Oh, wait. What am I doing? Solar radiation, that's only from the Yarkovsky effect, because it said that, right? Yeah, sun's radiation. And specifically solar radiation, right? Yeah. Risk of debris striking Earth, for sure. If you're bombing this asteroid, that's going to be a problem. Causes rapid change in the orbit. So that's going to be this one, because this one, it says, happens over a long period of time, right? Yarkovsky? Whatever, how you say it. Naturally occurring on small asteroids. The other one's going to be immediate. This was easy. But still, a little reading, 3 out of 10. Okay. Mount Morris Dam in the state park. What are we missing so far? What topics did we do? I don't think we had any plate tectonics so far. I wonder if we'll get them. We're already on question 38. There's 50, so we're coming to the end. No plate tectonics. Okay, Letchworth Gorge is located southwest of Rochester, New York, where the Genesee River flows. Okay, so southwest of Rochester, New York is sometimes referred to as the Grand Canyon of the East due to its height and the vertical face. The rock seen in the walls of the gorge consists primarily of shades and sandstones. Shales and sandstones. Okay, so that's sedimentary. These rocks formed during the late Devonian period. By the way, if you didn't know it was sedimentary, if you go to your rock cycle infographic, you can kind of find shale, which is right here. I draw shale right there, so it's in this whole area here is like basically your sedimentary section right there, and then basically like this area here is all your metamorphic, and then this whole area here is all your igneous generally. So yeah, so we're sedimentary. Okay. These formed in the late Devonian period. Okay, so that could be something to do with our geologic history, Devonian, right here. Maybe we're here, late Devonian specifically here. I'm just thinking of what they can ask. We got this sections of rock. Devonian, shale, sandstone, limestone. Great. Okay, let's see. In the Letchworth Gorge, the Genesee River erodes sandstone and shale at different rates. Check the box to indicate which one is more resistant, sandstone or shale. So let's see. So shale is here, sandstone's here. It looks like if you could see the sandstone, it's sticking out more on all of them. So sandstone's going to be more resistant. It's literally like sticking out. Like this shale is back further than the sandstone. So, sandstone. So we'll say sandstone is visibly sticking out further. I think that would be considered good enough. So that's pretty easy. 3 out of 10. It's just like annoying because like they got to come to the middle of the road with all the questions and a couple easy ones and a couple of hard ones, but there should be no 8s and 9s on this test, in my opinion. There shouldn't be. Maybe like a 7. Like make this a 7 your challenging questions. There's no need for it. They're too hard. The photograph below shows the gorge in the park of the Genesee River. We got X and Y. So look, this is the outside of a river and this is the inside. So things we know about this. The outside of the river, that's going to be where all your erosion is happening. It's like really fast water. And then in the inside, you could see it right there. That's where all your deposition is happening. Because it's like all slow and then all this stuff is deposited right there. You could see this area here is all deposited. Okay. The safest route should be near. I just covered everything, so I can't even see. Location X. Because this is where it's all deposited. Look at all that extra land. So this is going to be... How do I even choose something? X? Because at Y, there's a greater chance of weathering and erosion due to... Gravity? This is a weird choice here. It would be from water. I mean, I guess you could say this mountain here, the side of it might be a problem. So I guess gravity, because of the cliff, which increases the risk of landslides. That's probably what they were going for there. Oh, XY gravity landslide. I didn't even see this part. So that's the one I would pick. Kind of weird. Weird. I would say this is 5 out of 10. It was kind of easy, but I also have a lot of background knowledge. So, I mean, I'm trying to put this, rate it for a kid. So I would say it's probably like a 5 out of 10. Because some kids are going to pick flooding right when they see this picture immediately. So they like some kids will eliminate, and then they might pick. I don't know. I would just say they're going to pick flooding. All right, number 40. What are constructive process? What are the constructive processes? So that means something's being created, most likely responsible for the distribution of rock layers. So now we said it was sedimentary. Remember? Shale, sandstone, limestone. So we need to make sedimentary rock. So solidification is igneous. Recrystallization, that's metamorphic. Erosion, possible. Precipitation, possible. Folding, that's metamorphic. Burial, compaction, boom. 44. Sedimentary, easy money. 2 out of 10. There are multiple stream monitoring stations located along the Genesee River and at the Mount Morris Dam to collect data. Okay. The graph below shows some information about the river. Okay. Elevation before the rain event. Now the river is much more, and then water is released. So obviously when there's a rain event, the river gets higher. Okay. Which statement identifies how the construction of the dam has impacted the ability to control rain events? Construction of the dam has controlled river elevations to increase the availability of fresh water for the evidence. So look, rain event water stored. Increase the availability of fresh water for the residents of Rochester. Maybe. Construction of the dam has controlled water levels, reducing the chance of flooding and property loss. For the rain event, the river height was here. And then after the rain event, the river height got higher. Construction of the dam has controlled river elevations so that more swimming areas could be created. Where are they getting this from? Construction of the dam has controlled the amount of erosion, causing more sediments to build up. Okay, I'm missing something. Which statement identifies how the construction of the dam has impacted the ability to control rain events? Okay, did I miss something? I don't see anything about swimming areas for people. So I don't know where it's getting that from. Especially on this time. So look, 28, 29, 29, 30, July, July. So this is over like 2 days. Has controlled water levels. It hasn't controlled the water levels because the water level goes so high. Controlled river elevations. More swimming areas. I don't like that choice. Control the amount of erosion in the river, causing more sediment to build up in the water system. I'm leaning towards this because it says there's water stored. Construction of the dam has controlled river elevations to increase the availability of fresh water. And we're trying to control rain events. Causing more sediments to build up in water systems. I don't think that's probably right. I'm leaning towards 1. The graph shows information about the Genesee River during a rain event. Before the rain event, the elevation was 547 or 587, and then the rain event happens. And then look at the water stored. So the water is stored in the dam here, and then they release the water? I don't know. I am missing something on this question because I don't understand how a student is supposed to know this. There needs to be more background or information. I don't know anything about this area. Like, they gave us a picture. There's no dam. They didn't show where the dam is or what that looks like. This is just talking about the rocks. This is the worst question on this test. Well, if someone wants to tell me how they would solve this, or how a kid would solve this, please leave your comment in underneath the video, because the answer to this is 2. Construction of the dam has controlled water levels in the river. Okay, controlled water levels. Reducing the chance of flooding and property loss. I just don't, I'm missing something on this one. Well, sorry team. Yeah, like I said, comment about what I'm missing in this question, but it's terrible. Yeah, I got nothing else to say about that question, 41. All right, we're moving on. Base your answers to questions 42 through 45 on the information. Okay, energy and mineral resources. I'm going to pretend that last question didn't exist for a little while. The shift towards renewable energy resources is growing. Okay, yeah, renewable. Mineral resources such as copper, nickel, zinc, and rare earth minerals are important. Yeah, they are critical for the production of traditional and renewable energy sources, and also a lot of other stuff. The United States imports more mineral resources than it produces. Okay. Other countries work towards similar clean air transitions. Okay. The U.S. will be required to compete with other countries. Yeah. There's an open pit mine near Salt Lake City. We got copper. Okay, now we're talking about how to mine copper. Model of mining is potential. I mean, I'm just shocked at this test, honestly. This is not a good test. Like, it's not fun to take. It's just like a complete slog. And it's sad because we do such a good job in the classroom and have a good time and learn about all this stuff, and then they give these slog of tests that are just brutal. Okay. Model of mining and its potential effects on the environment. Let's just see what they have to say. Student makes a claim that copper mines negatively affect Earth's surface, causing a change to the systems. Identify the information in the model that provides evidence for a negative effect and resulting in one Earth system that supports the claim. Okay, look, I'm just going to make this so easy. Look, traffic, exhaust from the truck. That's what I'm picking. I don't even have to look at all this stuff. Negative effect. Exhaust from truck pollutes the atmosphere. Boom. I mean, that was easy. I mean, you could put a lot of stuff. Look, groundwater contamination to the hydrosphere. You could say, oh, look, deforestation. Deforestation, land is clear, more erosion, killing of habitats in the geosphere or the biosphere. That's the one that I picked. All right, moving on. Over 50 kilograms of copper are used to make electric cars. Students research information on the difference between gas and electric cars. Okay, let's see. Let's just look at the question. When comparing, which statement correctly summarizes the type of car that has a lower environmental impact? I mean, related to the mining industry, I know, based on this test, they're going to say electric cars. So we'll probably assume that the answer is electric, but we'll check anyway, just to make sure. The electric car has lower environmental impact from mining because the motor only weighs 76 kilograms for 234 miles. Look, 76 kilograms, 234 miles. Okay, so that's possibly right. But yeah, let's keep going. The electric car has a lower impact because it emits only 32 grams per mile. Look, 32 grams per mile. And uses only 53.2 kilograms of copper. Look, can contain more than 1 mile of mined copper. 53.2 kilograms. So this could be also right. Now, as opposed to 22.3 for the gas for copper, because remember, we're just relating to the mining industry. So the gas powered car has a lower environmental impact because it only uses 22.3 kilograms of copper and has a medium driving range of 403. That looks like it's possibly right. That's more right so far, relating it to the mining industry. The gas powered car has a lower impact because it costs about $500 more to operate. I mean, that doesn't good. And only releases 411 grams of CO2 per mile. That's terrible. Look at that's really bad. So it's going to be this. Surprising. Surprising, but remember, that's only related to the mining industry. So, I don't know. It's a reading question. I'll call it a 4 out of 10. It's like right down the middle. That's fine. All right, copper is affordable and versatile material. It's critical for economic development. We got an infographic. How exciting. Really exciting. Like, are there going to be any plate tectonics? I want to scroll down and see, but I guess I'll wait. Let's just read the question. Which explanation uses evidence from the infographic to most correctly explain how human activity is being influenced by the availability of copper used in the manufacture of new electric cars? Okay, let's just look. We're mining a lot of copper. The value of all above ground copper is 4.2 trillion. Using the 2019 average price of $6,042 per ton. So we're mining more copper. We're producing more copper. 5 countries hold most of the resources. If there were no new discoveries, it would take 105 years to mine all the currently known copper. Okay. As copper reserves are depleted, companies will be forced to lower the price of copper. No. It's going to go up. If there's less of it, it's going to go up. So that's wrong. The 5 countries with 65% of reserves will need to reduce copper production to conserve resources. No. Since global copper production more than doubled, that's true, all countries with copper reserves will need to open new mines to meet the immediate demand for the manufacture of... Okay, maybe. Copper recycling will need to increase in order to meet the demand for electric car beyond 105 years. Probably. That's probably more true. But it seems like they already are mining it. So, I don't know. 4 is probably the best answer, but 3 is also possibly an answer that a kid might choose. So I'm going to say this is not a great question. I would say I think these two are too good of answers. Let me just reread 3. Since global copper production more than doubled, is that true in itself? More than doubled? 9.8. Yeah, basically. 18. No, more than double. Yeah, that's pretty much. All countries with the reserves will need to open new mines to meet the immediate demand. I mean, that could possibly be true. But it's saying if there were no new discoveries required. Yeah, I think 3 and 4 are too similar. So I would say this is probably like a 4 out of 10 question, but I don't really like the question, honestly. All right, let's keep going. Human populations have, but like, going back to this, what's the point in giving kids ambiguity? Like, if they know what they're doing, you shouldn't have to make two answers that are so similarly in like that they could go between. And again, this is me with a lot of years of experience doing this. So for a kid, this is not nice. You know, like what are we trying to do here? All right, human populations have realized that there is a limited supply of traditional energy sources. For that reason, countries have been working on developing renewable energy resources. We've already done clusters on renewable energy. A lot. Like, we changed the topic. Like, where's the weather? Has there been any weather questions? I don't remember. Still no plate tectonics. In 2020, renewable energy sources made up 21% of all. Okay. 21%. Great. The graph below shows information about electric energy generation resources in the United States. Okay. We're producing electricity. Renewables produce a lot of electricity. And it looks like they're going to need more electric. Which evidence-based statement correctly describes how the electrical energy generation resources are projected to change? By 2030, hydro will surpass nuclear? Um, it's already surpassed. Nuclear is very low. By 2050, renewables will surpass natural gas as the largest source of electrical generation. It looks like it. This will be 1 to 3, and this is 3 to 5. No, it's about the same. Actually, maybe. Energy generation from coal is expected to increase by 2035. No, that's just going down. So that one we can get rid of. From 2020 to 2050, wind energy is projected to increase more than solar. I mean, that's true. Let's read 1 and 2. By 2030, hydro will surpass nuclear. I mean, unless I'm reading this graph wrong, no. It's already surpassed. I don't get this one. By 2050, renewables will surpass natural gas as the largest source of electrical generation. Renewables are here, so that if you measure from here to there, compared to here to there, it's very close, but I think that's higher. Oh, wait, wind energy is not projected to increase more than solar. Because look, solar is this gap, which is bigger than that gap. So that's wrong. So it's looking like this is the best answer. But it's so close. Like, why are we doing this to the kids? It's way too close. Like, what are you testing them on? If they can screw up how close these numbers are? Like, that's what the person who wrote this question is gonna get them on? Whatever. I mean, honestly, this is probably like we'll call it a 6 out of 10, but I hate the question. I would say like half this test, I don't like the questions. The Carboniferous period. Plants became firmly established on land during the Carboniferous period. Evidence of great forests and giant swaths has been found dating to the later part of the Carboniferous period. Dating to the latter part of the Carboniferous period. This changed the concentration of atmospheric oxygen. Okay, because we got great forests, so there's going to be more oxygen. It also resulted in a change of concentration of carbon dioxide. It should go down because there's more plants to absorb it, right? Yeah. So if there's more plants, it's going to take the carbon dioxide and spit more oxygen out. So that's good. This is a feedback loop. This is coevolution. Which claim accurately identifies the change in atmospheric oxygen levels due to a change in Earth's biosphere? Okay, oxygen levels increase, yes. So it's going to start us off all of that. As a result of deforestation? No. We're increased photosynthesis. Or decreased respiration. That's wrong. Decreased transpiration. Yeah, it's 3. Like, that is a great question. It's easy. It's straightforward. You know, you tested them on coevolution. You taught them about that. You interpreted some graphs. Like, this is a great question. I think all of them should be like this. Good job. Scientists claim Earth's surface air temperature changed during the late Carboniferous period. Okay. Analyze the data provided to support this claim by identifying the change to the Earth's atmospheric composition that will result in the temperature change. Also describe the temperature change. So if it's saying that does it tell you what happened to the change? No, it's saying carbon dioxide levels dropped, right? So in that case, we should be cooling. Change in atmospheric composition is going to be decreased CO2, so that means going to be identifying the change of the atmospheric composition that results in temperature change. If there's less CO2 in the air, there's lower temps. That's it. Again, great question. 5 out of 10, middle of the road. It's a good question. It's about the ancient atmosphere. You'll love it. Like, I think this is great. All right. Wow, we finally are getting Pangea. Oh my gosh. We got a little bit of tectonics, but we'll see. Students studying marine fossils from the early to late Carboniferous notice a substantial decrease in the number of fossilized marine species and rocks. While identifying this, okay, so let's just do this. Decrease in the fossilized marine species. several factors including sea level change, glaciation, and the movement of the plates. The graph shows information about sea level changes and changes in Pangaea during the same time period. Okay, so we got Pangaea, breakup of Pangaea, and it's saying the sea level up, down, so lowest sea levels during Pangaea. And then we break Pangaea up again, and the sea level went back up. Okay, we got a, well, I'm not going to, I'll let you know if it's good, but we got some plates. Okay, we got whatever, 340 million years ago, 310 million years ago. Okay. Some Carboniferous rocks contain fossils of the dragonfly Meganeura, an extinct insect related to modern dragonflies. It's a big dragonfly. So they shrunk over time, and there's our human. And we could see there's more oxygen, which caused the creature to be bigger, because they're going to increase oxygen and makes them bigger. Construct an argument that predicts the wingspan of a dragonfly if it were to have lived in the conditions that existed 200 million years ago compared to modern day. Predicts? Okay, it's going to be bigger. I mean, it's very established. The wingspan of a dragonfly, if it were to have lived in 200 million years ago compared to modern day. So modern habitat is 21% oxygen, and we have 19 centimeters. If it were to have lived in the conditions that existed 200 million years ago compared to modern day or Carboniferous dragonfly species. Oh, okay. So this is how long ago? Carboniferous? 310. And now we're going back 200 to 200 million, so we're getting closer to our time. So we're going to say O2 levels went down, so wingspan would go down. So we're going from Carboniferous, which was 310 million years ago, to, you know, now it's less, and they want to know what at 200. So it's going to be less, so the wingspan will go down. So that's pretty easy, honestly. Again, middle of the road, though. We're on question 48. Everyone's tired. You know, we're going through this test, 3-hour test. We're getting to the end, or we've ran out of time by now. So, you know, it's unfortunate, honestly, the way that this is built. The students summarized their research from the graph and the maps to make a claim. A decrease of marine organisms from the early to late Carboniferous period is a result of sea level change and glaciation. Okay. Which pieces of evidence from the maps and graphs support the students' claim? Okay. An increase in glaciation added ice to the cryosphere, yes, and lowered the water levels in the hydrosphere. That's true. An increase in water levels in the hydrosphere was a result from melting ice from the glacier. Yes, but that's not going to decrease the marine organisms. That's going to make it more. So I'm going to say that's out because that's going to make more marine organisms. Water levels in the hydrosphere and the amount of ice both increase. No. Water levels in the hydrosphere and ice levels both decrease. No. So the one that supports this is going to be 1, because basically if you're freezing the water, the marine organisms don't have anywhere to go to live, so that's going to support that claim. So I would say that's a 1. That's question 1, and it's a 3 out of 10 difficulty. All right, we're on the last question, and we have the carbon cycle. Wow, okay, carbon cycle. Carboniferous coal deposits can be found worldwide. Vegetation from the forests accumulated in large marshy areas. The biomass was buried and became layers of peat. The model below shows some information how coal forms. So basically you're taking the carbon out of the atmosphere, the plants are sucking it in, and then that stuff is being buried and became peat, and then that turns into coal, and then the carbon is now trapped in the coal for a very long period of time. Cycling of carbon through the spheres results in different stages of coal formation. Which piece of evidence could support the claim that the environments that environments of early coal formation can be found in New York State. Watertown, located, oh my gosh. So let's just go, we're going to relate this town to the area, and we're going to eliminate based on that so far. So this is a reference table. So we're going to go here. We're going to go to our New York State maps, and we're going to start finding these places. So let's just go one at a time. Watertown. Is Watertown in the Erie, Ontario lowland? So let's go check. Watertown's here. We're going to go see if that area is in the Erie, Ontario lowlands. It looks like yes, but let me double check. Yeah. So that's good. Glens Falls is located near Hudson River Valley. Okay, Glens Falls. Glens Falls right here. And is that in the Hudson River Valley? Oh, it's close. Glens Falls. It's like 43 and not half. 43.20. And there's no longitude on there, of course. It's very close. Whatever, we're gonna maybe. Geneva, located in Tug Hill Plateau. Geneva, that's probably not in the Tug Hill Plateau. No, Geneva's not in the, so this one's out. And then Binghamton in the Allegheny Plateau, that one I think I know is the case. Binghamton's here, and then Allegheny Plateau is down here, so that one's good. So, I mean, we got rid of one. Okay, now let's see. Does Binghamton contain peat, which forms into brown coal? Let's see. Does Binghamton contain peat? Peat, yes. So that's possible. Does Glens Falls contain cement? Where's Glens Falls? 27. There's 27C cement. Yes, it does. Which forms from coal? It doesn't say anything about cement. Cement doesn't form from coal. So that's not right. Over here it says brown coal. Yeah, look, peat, which forms into brown coal. Look, boom. So this is probably it. Watertown contains carbonate rock. Watertown 13 here contains carbonate rock, which is the solid. That's true, yes. Which forms into brown coal? No, it's 4. I mean, annoying with the maps, but easier question. Again, 4 out of 10. Like, the question's fine. Like, I don't hate it. All right, we did it. I would say that there's only one question on this whole thing that I thought was the worst. And there was some bad ones and mostly easy. But for a kid, I would say, honestly, my overall rating of this. So this is my overall thoughts. Like, I would be shocked. I don't know any kids that are really like, oh wow, like I'm surprised that my best students this year wouldn't be able to get 100 on this. I don't think that any of my best students would be able to get 100 on this test. I really don't. And I'm not discounting them. They're brilliant. I just think the way the test is designed, it's not like aligned to the kids who take this test. So I would say like just some of the questions were ambiguous. They were not written well. So the graphs, the amount of reading, I mean, the amount of pages, how many pages is this? 57 pages. I mean, of just stuff, you know, like no normal kid's going to be able to deal with that. I'm exhausted after dealing with this. So overall thoughts, I thought this was very hard test. Like this was maybe the hardest one that they've given so far in terms of difficulty to get a good score. I'm not saying that the content's hard. I'm saying that it's hard to do well on this test the way that they wrote it. So I'm going to say like this is like an 8.5 out of 10 in difficulty. Very like this was hard, poorly written questions. Too much. Again, too much too many diagrams, length is too long, too many charts. There's like multiple, there's like three pictures per question is too much. It's just, and then you're flipping all these pages back and forth. So for a kid to do well on this, it's just set up against them, and it's not right. That's my thoughts about it. But besides my thoughts about it, I hope that me going through it, you learned a little bit, you took something away from the way that I'm tackling these questions. If you have any questions or comments, please leave them down below. I'm interested to hear what you have to say. If you have differences in opinion, or if you think I misinterpreted a question and you have another way for me to go back and look at it, please, leave a comment and tell me which one and what you think. All right, thanks for hanging out, and I'll see you on the next one.